Good afternoon students. Welcome to the maths class. In this video class, you will learn about the chapter squares and square roots. Today I will discuss about the square of a number and some properties of square numbers. You have already learned about the integral exponents of rational numbers. When the exponent of a number is 2, it means the number is multiplied by itself. That is, the number is multiplied for 2 times. And so we can say that the number has been squared and the product is the square of that number. So, the square of a number, so we can say the square of a number is that number raised to the power 2. Square of a number is obtained when we multiply a number by itself. For example, we can write it as a number 5 square is equals to 5 is multiplied by 5 and that is coming 25. So here 25 is called the square of 5. Thus, if a is any number, then the square of a is written as a square and is given by a square is equals to a multiplied by a. You can take any example. Suppose 2 square if I write, then 2 square means what? 2 square means 2 is multiplied by 2 and that we all know, that is 4. Suppose if I write 3 square, then 3 square means 3 multiplied by 3 and that is 9. So you can write any other examples also, square of any other numbers. Now look at this figure. This is a square figure with side measurement 4 cm. Now in this square, let us divide the any two adjacent sides into 4 equal parts. Why 4 equal parts? Because the length of the measurement is 4 cm, so we can easily divide it into 4 equal parts. So let us divide it into 4 equal parts. I am doing, you will do this measurement with your scale. So, if you divide into 4 equal parts, then you can see that all the sides are divided into 4 equal parts. And how many equal parts, equal squares you are getting a squares. So, how many squares we are getting? 1, 2, 3, 4. Then plus 4 again, that means 8. Plus 4 again, that means 12. Plus 4 again, that means 16. So, total 16 small squares we are getting, each of measurement 1 by 1. Because these are all divided into 4 equal parts, so each measurement will be, each of the size, this length will be 1 cm. So from this square we can write that area of this larger square is equals to what? Area of 16 small squares. Now area of a larger square, its side is 4 cm and we know area of a square is side into side. In a square all sides are equal. So we write it here 4 cm multiplied by 4 cm. So this is equals to 16 into area of one small square. That is, this one small square area is 1 by 1 centimeter square. That means 1 centimeter square. So this becomes 4 multiplied by 4 centimeter square and that is equals to 16 centimeter square. So this implies 4 multiplied by 4 is equals to 16 and we know 4 multiplied by 4 means what? 4 square is equals to 4 multiplied by 4 is equals to 16. So we are getting a result from this figure, square figure, that 4 square is equals to square of a number is equals to the number is multiplied by itself. So, when a number can be expressed as the product of two equal factors, then the number is called a square number. Now, with the help of this, I have taken 4 cm. You will try yourself with 3 cm, 2 cm, 5 cm. And just draw like in this way. You just divide, when you are taking 5 cm, divide it into 5 equal parts and see that what results you are getting. you will get that square of a number is equals to the number multiplied by itself, you will get. So this is a very, this you can also geometrically show. The square of a number is the number multiplied by itself. Now let us draw a table to show the squares of first 20 natural numbers. Look at the table. The following table shows the squares of first 20 natural numbers. Here the numbers from 1, 2, 3, 4 up to 20 is shown, and the square of the number 1 square equals to 1 multiplied by 1 equals to 1. 2 square is equals to 2 multiplied by 2 is equals to 4. 3 square is equals to 3 multiplied by 3 is equals to 9, and so on. So 20 square is equals to 400. Up to 20 square it is shown here. So from the table it is clear that the natural numbers 1, 4, 9, 16, so on up to 400, it is present up to 400 are the squares of the natural number 1, 2, 3, 4 up to 20. So here we can say that the square numbers 1, 4, 9, 16, 25 and so on are the perfect squares or square numbers. So in other words, we can also say that a natural number is said to be a perfect square if it is the square of some natural number. Or in other words, we can say that a natural number n is called a perfect square if there exists some natural number a such that n is equals to a multiplied by a is equals to a square. For example, if I write 7 square, suppose if I write 49, then 49 means 7 multiplied by 7 is equals to 7 square. So here 49 is the perfect square, or we can say square number. Thus, a natural number which can be expressed as a product of pairs of equal factors is known as a perfect square. Now, let us discuss some properties related with the perfect square, or we can say square numbers. Now look at the table. From the table, can you tell how many perfect squares are there up to 100? See 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. So total there are 10 perfect squares are there up to 100. Now if you see the table, then from this table all the square numbers are end with either 0 or 1 or 4 or 9 or 6 or 5 at its units place. None of the square numbers ends with the digits 2, 3, 7 or 8 at its units place. So from this we can say that a natural number having 2, 3, 7 or 8 at its units place is never a perfect square. That means any numbers ending with the digits 2, 3, 7 or 8 is never be a perfect square. So from this property, it is a very important property. With this property we can easily say that whether a given number is a perfect square or not. So for example, if I write some numbers, suppose if I write 333, so as the unit place digit is 3, so it is not a perfect square. So if I write suppose 278, as the unit place is 8, so it is not a perfect square. Similarly, if I write 212 or one more 2, if I am adding any number you write, any number of digits you write, so by seeing the unit place of the number of this numbers, we can say that this number is a perfect square or not. So one more example, if I write 17777 and so on, 1 up to this, so here the unit place is 7, so it is also not a perfect square. So a very important definition is that a natural numbers having 2, 3, 7 or 8 at its unit place is never a perfect square. So whatever the number is given, and if it is asked that whether a given number is perfect square or not, we will check the unit place of the given number. and if it is present 2, 3, 7 or 8, any of the one digit is present at its unit place, then that number will never be a perfect square number. Come to the next very important points, that from this square numbers we already got that this square numbers are all ending with either 1 or 0 or 4 or 5 or 6 or 9 at its units place. So from this we can also get a very important property. A natural number having 0, 1, 4, 5, 6 or 9 at its unit place may or may not be a perfect square. For example, if I write, first suppose 0 is given, if I write 100, yes, it is a perfect square. But if I write 10, its last digits is 0, but it is not a perfect square. On the other hand, if I write 121, yes, it is a perfect square, but 21 is not. See 144, yes, it is a perfect square, but 44 if I write, it is not. Similarly 50, 225, yes it is, but 55 is not. If I write suppose 256, yes it is a perfect square, but if I write 66, it is not. On the other hand, it is 9, so suppose if I write 49, yes it is a perfect square, but 19 if I write, then it is not a perfect square. So we will get many examples that many of them are perfect square, many of them are not perfect square. So in this case, so we cannot say directly that the given number is a perfect square. So it may be or it may not be. So in our next class, we will discuss about the remaining properties of square numbers.